Hello and welcome to today's video. Today we will be going through trigonometry for triangles. This video will focus on foundation maps and trigonometry on right-angled triangles, SOHCAHTOA and missing angles. Once you finish this video, you can check the description and find a worksheet on foundation maps problems. If you are a higher math student, there are more things to learn. The second video will cover the rest. That will be tan-sine relations, exact angles, non-right-angled triangles, and harder multi-step problems. You can find the link to the second video in the description. Okay, let's get into the video. So, trigonometry on right-angled triangles. The first thing that we need to know is what is a right-angled triangle and how do we name the sides on a right-angled triangle. So a right-angled triangle is any triangle that has a right angle in it. That means 90 degrees, as shown here with that little box. Now, if we want to use trigonometry, we will always be dealing with one other angle at least. And we may want to find that angle, or we may want to find sides using that angle. I will label the angle here as theta. Now, we also need to be familiar with the names of the sides. The names actually have a logic to them, and let's look at that. First, we have the hypotenuse. The hypotenuse is always the longest side on a right-angled triangle, and you'll always find that exactly opposite to the right angle. Then we have the opposite. The opposite, in its name, right, is opposite to theta, the angle that we are dealing with in our trigonometry practice. Then we have the adjacent. Adjacent means next to. It's next to the angle that we are dealing with in our trigonometry. So opposite, opposite to the angle, adjacent, adjacent to our angle, hypotenuse, longest side, opposite the right angle. The next thing that we will have to know is SOHCAHTOA and the equations relating to the sine, cosine, and tangent of our right-angled triangle. There is a logic to SOHCAHTOA. First, it's split into three parts. SOHCAHTOA, like so. It's a phrase that we can use to remember the equations for sine, cosine, and tan. So, S is the first letter relating to sine. Then we have an O and a H. O standing for opposite and H hypotenuse. The first letter is the numerator on the other side of our equal sign. The second letter will be the denominator. Applying this same rule, we can see that cosine for C, adjacent above, hypotenuse below, and then for tan, opposite above, adjacent below. You may not need to remember this. Some exam boards will provide you with these three equations. However, some don't. So do try and remember them if you can. It will make your questions faster anyway. We know the three equations now, but how do we actually use them? Well, let's say I draw a right-angled triangle, like so. And let's say that I give myself an angle, let's say 30 degrees. And now I am going to say that the hypotenuse, the longest side, is 15 meters. What if I were to ask you the value of x, this side over here. How can we use our equation? Feel free to pause the video before the solution. Okay, so the first step is identifying which sides we're dealing with. First of all, this 15 meters is opposite the right angle. And as I've said, it's the hypotenuse. Then we have this x that we want to find. X is opposite to our angle. So we put an O there, it's the opposite. The next thing to do is to look at which equation, sine, cosine, or tangent, we need to use. We want to use an equation which has the hypotenuse and the opposite. That is sine. So we put in our values. We're using the equation of sine theta equals opposite over hypotenuse. Let's substitute that. Sine 30 equals opposite, which is x, our unknown, over hypotenuse, which is 15 meters. And now we have an equation. All we need to do is solve it. Multiply by 15, and we get x equals 15 sine 30. And we can put that in a calculator, and we will get 7.5 meters. And there we go, we've done it. Now, if you are happy with that working, you can try, as a challenge to yourself, find y, this side here. You'll have to use one of these two equations. So, did you give it a go? We're using now the adjacent and the hypotenuse. That means we need to use the cosine equation. So, cosine of 30 equals adjacent, which is our y, divided by the hypotenuse, which is 15. Rearranging for y, we get y equals 15 cos 30, which is 13 if you round it. So far we've been doing problems on missing sides. We can also, however, use the sides to find the angle. Let's try that now. Say you are given the following triangle. We have a right angled triangle with 7 and 9 on these sides. And we're asked, what is this angle x? Well, we need to start with the same approach as we were doing for missing sides. And that is identify which sides we're dealing with. X is now the angle that we care about, so we name the sides relative to this angle. 7 is opposite to that, so this is the opposite, and 9 is adjacent, so this is the adjacent. So we need to use the equation which has the opposite and the adjacent from these three above, and that would be the tan equation. So tan theta equals opposite over adjacent. Now let's fill in the values. Tan of x, which is now our theta, is equal to 7, our opposite, over 9. Now, how do we actually find x? Because x is inside this tan function. Here is where we need to use the inverse tan. So in order to get rid of this tan that's around the x, we take the inverse. So we do tan inverse on both sides of the equation. That will give us tan inverse of tan x, which equals tan inverse of 7 over 9. But the inverse cancels with that tan, so simply x equals inverse tan of 7/9, which I'm sure is what you're used to seeing instead of this line right here. But we're being rigorous here. Now, using your calculator and the inverse function, you can find that this value will give you 37.9 degrees. And there we go. We can find missing angles. Now, if you are a foundation student, this is all that you need to know about trigonometry. And you can go ahead to the description and try the attached worksheet that will have questions similar to this. The answers will be at the back of the sheet. Let me know how it goes. If you're a higher student, remember to check the second part of this video. You can follow the link in the description, and there you can learn about the rest. Have a nice day.